Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. And it's called Split the Sums by Palpot. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 in each row, column, and 3 by 3 box. We have global constraints, where we have regional constraints, where each constraint type may contain no repeated digits anywhere in the puzzle. So that means there are no repeats on any line in the puzzle. So keep that in mind. We have meta renban, where the digits along each line must sum to a unique number, and the sums of these lines must form a set of consecutive numbers. And this refers to all line types combined. So that means we have, I think we have 8 line types. Therefore, they must form essentially a set of consecutive digits without repeats. I'm assuming. Because it doesn't make any sense that you could go like, you can't go like 10, 11, 10, 11, 10, 11, 10, 11, right? Because that would sort of defeat the purpose of essentially the renban. But it would be essentially something like from like 10 to 17 or 11 to 18 are the sums of all the lines, or something along those lines, right? So that's the meta renban. Then we have local constraints. Oh, right. We have 4 different types of lines. So each constraint type may contain no repeated digits. So along the parity lines, I should say, there are no repeated digits. Along the entropy, or I think this is tentropy line. Yeah, tentropy lines, there are no repeated digits. Along the German whisper / whisper 5 lines, there are no repeated digits. So say you had like a 3 here, you could not have a 3 in the other German whisper line or along the rest of this same German whisper line, right? That's what it means to have regional constraints. What are the local constraints? For tentropy lines, where every set of 4 adjacent digits on a each tentropy line must contain a digit from each of the x pairs, 10 pair subsets of 1, 9, 2, 8, 3, 7, and 4, 6. A 5 may not appear on a tentropy line. So for each set of 4 digits on the tentropy lines, on the peach tentropy lines, you have to have one digit each from the subsets. So you could have something like, say, 9, 4, 3, and 2, and this would be a valid tentropy line because 9 is from the subset of 1, 9, 2 is from the subset 2, 8, 3 is from the subset 3, 7, and 4 is from the subset 4, 6. So that's an example of how tentropy lines work. We also have German whisper lines, or as I like to call them, whisper 5 lines. I did not come up with it. A setter came up with the naming and basically said, I'm going to call these whisper 5 lines. And I thought it made sense because it's very extensible. You could use whisper 4 lines, whisper 3 lines, whisper 6 lines, etc., etc. And that's why I call them whisper 5 lines. But no, when I say whisper 5, it's the same thing as a German whisper line. Well, 2 cells connected by a green line must have a difference of at least 5. So, for example, if this were, say, a 3, this would have to be 8 or 9, because those are the only digits which are 5 or more away from 3. And that's how a whisper 5 / German whisper line works. We have modular lines, where any set of 3 sequential cells along a teal modular line contains 1 digit from 147, 1 digit from 258, and 1 digit from 369. And those are the sets that of the digits that are modulo 3. So if you divide the digit by 3, you'll get a remainder, and that would be what modulo it's in. So 147 is 1 modulo 3, 258 is 2 modulo 3, and 369 is 0 modulo 3. And you could have something along the lines of, say, 4, 2, and 9. And that would be valid for this set because these 3 digits would have 1 digit from 147, which is 4, 1 digit from 258, which is 2, and 1 digit from 369, which is 9. And that's an example of how modular lines work. And finally, we have parity lines, where adjacent digits along the red line have a different odd-even parity. So, for example, if this were, say, a 3, then we know this digit would have to be even, and it could be something like 8 or something like that, or 4. And that's an example of how parity lines work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, for the parity line, we have all 9 digits because of the regional constraint, global constraint. So they must add up to 45. For the tentropy line, they add up to 40. We have 8 lines. So, okay. We know 5 cannot appear on the Whisper 5 lines. So for the tentropy lines, they have to add up to 40. The parity lines add up to 45. There can only be a difference between the lines of what? Of at most 7. So to add up to 45, it could be 22 and 23. What are the possibilities? So the parity lines can add up to either 22 or 23. What else? Well, this is going to be a lot of possibilities. So, what are the largest differences? 7, right? Because you have to have 10 to 17 or something along those lines, but since it's going to be at least 45, that means, okay. Um, 22 to 23. What's the most? What's the highest? So it could be up to 27? No. 27 would have to be with 18. That's the difference of 9. So it could be 25 is the most with 20. 23 is the next with 22. 21. 21 with 24. 19 with 26, and that's the largest difference. So these are the possible sums on these lines, on the parity line. 19 to 26, 21 to 24, 23 to 22, 25 to 20. What about these? They have a they add up to 40. So the possibilities are 10 and 30. Obviously, it's too big of a difference. 12. So obviously you can't have 20 and 20. 17 and 19 work. So 17, sorry, it's 19 and 21 work. So this will be the smaller one, 19 and 21. 18 and 22, 17 and 16 does not work. 16 and 24 are 8 apart. So 21, 22, 23. Okay, so these are the sets here. So if we tried to have 26 and 19, that does not work because this has to be a teens and this has to be 21. So this cannot be 26 and 19. If this is 21, okay. And this is 7, and you cannot have a 5. Hmm. Okay. It has, this has 2 high and 2 low digits. Because on a Whisper 5 line, you'll alternate between low and high digits. Because what digits can be next to a low digit, which is 1 through 4. 1 can be next to 6 through 9. 2 can be next to 7 through 9. 3 can be next to 8 or 9. And 4 can be next to 9. So those are all high digits next to the low digits. And you have the same vice versa with the high digits. What digits can be next to high digits, which are 6 through 9. 6 can be next to 1. 7 can be next to 1 or 2. 8 can be next to 1 through 3, and 9 can be next to 4. 1 through 4, which are all low digits. So this is... We're missing either 1 high or 1 low digit. So that means... Can you be missing... You could be missing a 1, right? Can you, though? You cannot be missing a 1. If you're missing a 1, the problem is what is 6 next to, right? On a Whisper 5 line. That means you also can't be missing a 9. So you have to be missing 2, 3, or 4, or 6, 7, or 8. So they add up to 38 at most. And 32 at least. If they added up to 32, so the largest sum here with 2 unique digits, sorry, the smallest largest sum with 2 unique sums, I think is 23, right? 20 and 25, 25 is the largest. 22 and 23, 23 is the largest. 24 and 21, 24 is the largest. So 23 is the smallest, largest sum which means it has to go from 23 all the way down to at most 16. So we cannot have a sum that's 15 or less. The sums have to be at least 16. So if that's the case, then you cannot have two be missing because 32. So, sorry, you can't have 8 missing because 32 must be 15 and 17 because they have to be at least different sums. And 15 is too small. So in the Whisper 5 lines, you cannot be missing 1, 8, or 9. You could be missing 6, you could be missing 7, 2, 3, and 4 are also valid. What about the modular lines? They could be 36, which is missing the 9. And that does work because you could have 17 and 19 potentially. Yeah, that's interesting. That would force this to be 18 and 22. Can this really be 23? No. Well, maybe. 17 and 23. So here you're missing 5 at least. And 2. So for the global, it cannot be 32 you're missing. It could be 33 all the way up to 38 with missing a 2. Hmm. Okay. Hmm. Okay. Um, 33. Okay, it can't be 33 either. If it's 33, that means this would have to be 16 and 17 because 16 is the smallest it could be. 16 and 17, which eliminates 17 here. This would have to be 22 and 23. So therefore, this would be 21, 19. Oh, actually, that does work. 16, 17. 16, 17, 21, 23, 22, 23, 21, 19. That leaves... Hmm. Um... Hmm. So the smallest... Okay, let's keep that, I guess. The smallest number this could be is 16. Let's, I guess, put that in the 3 set. So 16 could be here. 17, the smallest, largest number is 17. Up to 38. 38 could be 18 and 20. So the largest small number is 18. So this is 16, 17, or 18. Okay, the smallest number is 16, 17, or 18. We're just using that as an example here. These have to be all odd sums because you have 5 digits here, and it can't be 3 evens because we have 2 and 2 here. So that's why this is all odd. This could be 17 to 20, right? So 17, 18, 19, or 20. So those are the possibilities. Hmm. Yeah, it seems valid. Modular lines. Again, the minimum is 16, so we'll use that as 16 here. You can go up to 44, though. So the largest small line would be 21. 16, 17, 18, 19, 20, 20, and 21. What's the largest sum you could have? You could have 16 to 20. 18 to 25 is possible. 19 to 26 does not work because 19 and 26 add up to 45. We're missing one digit on the modular lines. So this is also a max of 25. So 25, 24, 23, 22. 21, 20, 19, 18, 17 is the most. No, 17 does not work. 17 and 16 add up to 33, which is more than what a single digit can be. 18 doesn't work either because 18 and 17, which would, this is the higher number. So 18 and 17 would add up to at most 35, which means the remaining digit would have to be a 10, which is not a digit. 19 does work. So for the modular lines, you could have 19 all the way up to 25 as the largest sum. Can you actually have 21 as the largest? Sorry, 21 as the smallest of the sums. Can you actually have 25 here? I think the answer is no. If this is 25 and 20, we have 3 digits that must be 20 or less. So that, or three sums that must be 20 or less. So that means we have three sums are 20 or less. So that means it's guaranteed 19, 18, 17. And 20, 17, 18, 19, 20, 21, 22, 23, 24, 25 is too large as a Renban, right? 17, 18, 19, 20, 21, 22, 23, 24, 25 is 9 lines. So this cannot be 20 and 25. We know then it has to be 21 or 20, 22, 24, 21, 23. Okay, so one thing we know then is if it's 23 and 22, this has to be 21 for this sum, right? If this pair is 22, 23, this has to be 21 because there's no other place for it. Otherwise, this is 24 and 21. Either way, 21 is removed as a possibility for any of the other sums because we're guaranteed one of them on the parity line here. Okay. So this could be 20. It could be 19. Well, okay. So then what are... This could still be 25. Yeah. If we had this being 19 and this is 18 as a smaller one, 19, 18 would guarantee this is 17 and 23. Right? Because 19, 18, 17, 23 to add up to, these must add up to 40. So 19, 18, 17 would guarantee this is 16. That's 23, but then this would have to be 21 and 24 because this can't sum to 23 anymore. And that's too large. Right. So So we're guaranteed one set, this sum, the lesser sum of the Whisper 5 line is 16, 17, 18. We have one from 17, 18, 19. If we use 19 and 18, that would guarantee this is 17, this is 16. And this would be 20. But the problem is then this would be 17 and 23. And then this would have to be 21 and 24, which is too large. 16 to 24 is too large. So this cannot be 19. So we have 20, 22, 23, 24, 25 as the possibilities. Can this actually be 25? Seven away from 25 is 18. So this would have to be 18. This would be 19. So if we had 25 here, this is 18, 19. 19 is with 21. So it could not be 21, 24. We'd have 22, 23. So 25. Again, this would be 18. This would have to be 19. But then the problem is this couldn't be less than 25. Or this couldn't be less than 18, which is 7 away from 25. And this cannot be 20, because if it's 20, 20 and 25 add up to 45. which 8 unique digits does not add up to. So this cannot be 25. So this has to be 20, 22, 23, and 24. Interesting. So this is 22, 23, or 24. Or 20. Well, if this is 20, that's interesting. So if this is 20, this has to be less than 20. This has to be less than 20. This is less than 20, and this is less than 20. So we have the must have the sum 16 through 19. (16 through 19), therefore it must be 22 and 23 here. Therefore it's 21 and 19 here. And that, I think, works. Right, this would be, so 20. This would have to, one of these would have to be 16. This would have to be 19 because this is 22 and 23. So you have 21 there. 19. So 20, 19, 21, 22, 23 is there. One of these is 16, and we have 17, and then 18. Oh, that doesn't work. Because... Actually, that could work. Never mind. Yeah, that could work. Yeah, this doesn't have to add up to 40 or whatever. It can be, it's 33 to 38. And this is 30, this adds up to either 36 to 44. Okay. We know this adds up to 45 and this adds up to 40. Maybe I should just... So that's a guaranteed 85. I'm going to bring a calculator here because there's a lot of math involved here. So we're guaranteed 40 and 45. Okay, so what are these adding up to? So you could have 16 to 23. Oh, well, we know what they are then. 16 to 23 or 17 to 24, right? We tried 25 multiple times, and it just kept on not working. So 16 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 23 is 156. And if you subtract out 16 and add in 24, it's 164. So the sums must add up to either 156 or 164. Which are both even numbers. That's interesting. Okay. 156 minus 45 minus 40 is 71. Okay. So these sums are specifically 33, 34, 36, 37, and 38. Right? Okay, so 30, okay. So we know it just can't be 35 in between because we're missing a 5 already on the Whisper 5 lines. So that's why I can't be missing 2 5s. You could be missing 5 and 7, 5 and 6, 5 and 4, 5 and 3, or 5 and 2. You cannot be missing 5 and 9 or 5 and 1. And then the 8 doesn't work because that means if we're missing 8 also with the 5, the problem with that is that that would sum to 32, right? And 32 can only have a difference of sums of 15 and 17, but 15 is too small as a sum because we're guaranteed a 23 in one of these sums. Right. Okay, so then back to the summing. Okay. So 33 could be with 38 to add up to 71. $33 and 38 work. So I'm trying to think of all the sums possible here, right? 33 and 38 work. 33 is never going to add up to 85. All right, not 85. It's 164 minus 85. So 79. So they add up to, these sums add up to 71 or 79. Right? 71 or 79. So 33, oh boy, there's a lot of math here. We have 33 and 38 work. To add up to 79 is not going to work. It's 46, which that sum can never add up to. 33, 38. 34, 37 works. Not sure where to put these. Um, 33, 38, 34, 37, and 34, 79 minus 34 is 45, which obviously the modular lines cannot sum up to because we're missing one digit. 36 and 35 is too small to match the modular lines. So, okay, we have let's just clear this. So make it this way. This is 17, 18, 19, and 20. So we have 33, 34, 36, 37, and 38. With the 33 has to be 38. Right? Adds up to 71 or 79. So 38, 37 there. 36 must be 79 minus 36 is 43. So then this would be 43. 37, again, 71 minus 37 is too small. So it must be 79 minus 37, which is 42. So 42, and then 38 with 41. So these are the possible sums of the modular lines. So it can't be 36. It's 37 up to 43. And we are missing specifically 39 and 40 in between that. Yeah, let's just move this over to here, this section here. Okay, so 33, 34, 36, 37, 38. And this is 38, 37, 43, 42, and 41. Okay. So these are all the possible Whisper 5 sums totaled, and these are all the the modular lines totaled. So we are not missing on the modular lines. We are missing either 2, 3, 4, 7, or 8. So on the modular lines, we're missing 2, 3, 4, or 7, or 8, right? That's what the sums add up to. On the Whisper 5 lines, it's still the same. We're missing either 7, 6, 2, 3, or 4. Okay. Well, on the Whisper 5, we're also missing a 5. On the Tetris line, we're missing a 5. Okay. Here, okay, so this cannot be 20. Well, it still could be 20. And this could be 24 if this is like 19. We do need a guaranteed 20, and the 20 has to be on the modular line or the Whisper 5 line. Hmm. Hmm. Okay, what happens if this is 17 and this is 16? That's 33, so this must add up to 38. 16 and 17 would force this to be 22, 23. We'd have 21, 19. And then we'd have 20 and 18. I think that works fine. Um... This cannot be two lows and a high. Actually, it could be. It could be 934. Never mind. Oh, okay. Uh, Never mind. That's the only way it could be, though. Because that's the smallest, that's the largest sum that three unique digits with two lows and one high could be. Um, can you ever actually add up to 20 with the Whisper 5 lines? Yeah, 389. 389 works. Uh, uh, which means the other one would have to be 1, 2, 6, and 7. Yeah, that works. Okay. So we've narrowed it down to what the sums can be. It's either 16 through 23 or 17 through 24. Okay, what happens if this is 17? We have 17 and 23. So this must be 21, 24. We need a 22, so this has to be 22. So 1723 means this is 21, 24. This has to be 18. Um, Again, 17, 23, 21, 24. This cannot be 16, so this would have to be 18 here, which means this is 19 or 20. We need 22, so 22's here. This is 19 or 20. This must be 19 or 20. And that works. Hmm. Okay, this is where the very hard part is. We have to figure out how these interact with each other. Uh, 20, 22, 23, 24. If this is 24, that's interesting. That forces this to be 22, 23, so this is 21, 19. I don't think this can be 24. If that's 24, okay, so again, if this is 24, these cannot add up to 44 because of the sums on the Whisper 5 lines. So if this is 24, this cannot be 20. If this is 24, this forces this to be 22, 23, which means this is 21, 19. So this can't be 20, it can't be 19. Oh, wait, no, that works. That's plenty. Never mind. It could be 17 or 18 here. This is 17 or 18 here. This would have to be 20 here. Yeah, never mind. Never mind, that works fine. Hmm. Um, hmm. Huh. Um, yeah, I don't know why I chose this being the higher one and this being the lower one, while this is the lower version. This is the higher one. Um, Odd and even works. This being the smaller one makes sense because it's less, but it could actually be the larger one. Huh, so this could be 24. Oof. Can this ever be... It could be 20. If this is as a smaller one is 20, these is guaranteed to be 20 through 24. We'd have two more above 20 and one more above 20. So this would have to be 21 through 24. Um, yeah, and this would be 17 through 19 here, which is fine. Hmm. Uh, well, if this is 20, this cannot be 24. So it'd be 22 or 23, which means this cannot be 22, 23. It'd be 21, 24. So this would be 22, 23, which means this would be 18 or 17. So then this would have to be 19 here. That seems fine. Huh. Okay, what are the Whisper 5 combinations for 3 digits? Again, 3, 9, and 4 does add up to 16, so that does work. That's the only possible low, high, low. What about high, low, high? 619 works. That's 16. 719 works. 718 works, adds up to 16. 719 works. Hmm. Um, what other restrictions do we have? So 6 has to be next to the 1, 4 has to be next to the 9, and we know there is at least one 4, 1 6 and 4 9 combo on the Whisper 5 lines. You could have both, but if you're missing 4 or 6, that's fine. Uh, yeah, this is the very hard part. Interesting. So if this is 16 as the lower one, this cannot be 20 because 16 and 20 add up to 36, which is not a sum that the modular sums can add up to. So this would guarantee be 20. So you have 16, this would be 17, 18, 17, 18, 19. This would be 20. Oh, that doesn't work. Huh, so this cannot be 16. Right? Again, if this is 16, this can't be 20 because it must add up to 37 through 43. So the 20 has to be here. Therefore, we have 16. This is 17, 18, 19. We have 17 or 18, but we have no other sum that's between 16. We have no other sum that's between 17 and 19, and we only have two of them when we must have three. So this specifically cannot be 16. So we have 17, 18, 19, 20 as the minimum for the modular lines. Now this could be 17 and 20 here, and that would work fine. Actually, that doesn't even work. Well, no, it could be. 16 here, 17, 20, and this would be 18, 19 as a pair. Anything else? Oh, that's interesting. Okay, if we have if we are missing a 7 in the Whisper 5 lines, it has to be 17 here and 16 here. If we're missing a 7, that means these are too high, too low. This must be 1 high and 2 lows. So this is guaranteed to be 16 here. Therefore, this is 17 here. And this must add up to 38 for the modular lines, with one of them being 20. So if we have 16 here, 17 here, one of these has to be 20 and the other is 18. So this is 20. The higher one is 20. This is 18. This has to be 19, 21, and we have 22, 23 here. That works. Okay. If we're missing a 6, then again, this must be 3, 9, and 4 to add up to 16. This becomes 18. Again, so this would be 20 and 17 here to add up to 37. We needed 20. 20 and 17. We have 16, 18. This is 19, 21. And this would be, again, 22 and 23. So that works. If we're missing a 4, now that becomes a little interesting. That means we're missing a low. So this must be 2 highs and a low. Yeah, that's pretty broad though. Hmm. 3, 9. Hmm. Um. hmm. What would be interesting is if we could eliminate 3, 4, and 9 from being here, right? I don't think we can though. Yeah, it's gonna be really hard. Um. Hmm. Okay. Um. Hmm. Hmm. Say we're missing a 2. That means we have both 1, 6 and we have 4, 9. Oh, that's interesting. If we have both 4, 9, this has to be alternating between low and high digits, right? How about that works? You could have 4, 1, 9, 6. Wait, 6, 1, 9, 4. There we go. That works fine. Never mind. Never mind. 6194 adds up to 20. That's perfectly fine. Oh, but that doesn't really work. No, that doesn't work because you have to have 3, 7, and 8. And 3 would have to be between 7 and 8, which is not possible on a Whisper 5. 3 cannot be next to 7 on a Whisper 5 line. Huh. So if you have 1, 6 together and 4, 9 on the Whisper 5 line, it cannot be this set here. You could. Ah. So 6, 1 can't be here. If you have 6, 1, 9, the 4 cannot be next to anything on the rest of the Whisper 5 line. So the 6, 1 cannot be here because this must add up to at minimum 16. So the 6, 1 would have to be here, which would force this to be 9, 3, and 4. Because 4 can only be on the end. Interesting. So if we're missing a 2 or a 3, we still have to have. We can't be missing a 3. Oh, fascinating. Okay, this is probably the break-in part. So if we have on this line both 4 and 6, um, this has to be. You can't have this being 1, 4. Oh, you could. 2 can be next to 7 and 8. Oh. This was specifically for 2, I guess. right? So if we're missing 2, this has to be 349. How do we know this is only 20? Yeah, couldn't it be 21 or 22? Hmm. Ah, doesn't work. This cannot be right. Right, because you have 3 digits, 2 of which must be low, 2 of which must be high. You could have 16, 20. No. Well, maybe. I think you could actually have 21 and 22. Ooh. Okay, that leaves some of my assumptions bad. Uh, actually, but this still works, right? One of the eliminated sums might not be. Oh. These sums still work, but this could be 21 to 22. Ooh. Yeah. I don't know where I came up with 20 as the most. Hmm. That's bad. Okay, so this could be 21 or 22. Ugh. Um. Hmm. I'm gonna have to rework some of these then. Okay, so these are still the same. Are they? Maybe not. This could be potentially be 25. Ah, okay. Well, that was a bad assumption. These are still the same here, so that's fine. This could be 16. Ugh. 21, no 22. Um, so we could still have 21 here. Ooh. I think 25 is kind of okay. One of these is 20. That's the interesting part, right? Uh, okay, 2025, we are guaranteed at least 18. Okay, this still can't be 2025. 2025, that means we have to have 18 here, which means this is 20 here, and then that would be a contradiction. So that's good. We can remove that. So then this still has 21, 20. Okay. So this still has the same interaction here. Okay, that's good. We still could have 16 here and 21, potentially. Right. Okay, so these are still 21 and 22. But this was an interesting thing here, right? So if this is 16, this must be 22, 23. That makes this 21. Oh, well, there you go. That's why this can't be 21 or 22. Well, it can't be 22 specifically, because again, this must add up to 38. But also, if you try to have this be 17 and 21, you can't have 17 and 21 here, right? 3 digits can never add up to 21. on a Whisper 5 line because it's 3, 8, and 9 at most. 4 cannot be next to 8, obviously. And then you can't have 3 digits. If you're missing a 2, I guess that could kind of work. No, if you're missing a 2, right. If you're missing a 2, you have to have 2 lows here, and this must be 1 low and 2 highs. You cannot have the 4, 9 be there. So 4, 9 has to be along this. This is then 6 and 1, but that means the next highest digit would be 8, which is, and 6, 1, and 8 adds up to 15, which is too small. So 38 does not work. Right? Because the problem is 1 and 6 cannot be next to 1 and 6 have to be next to each other on the Whisper 5. 4 and 9 have to be next to each other on the Whisper 5. So, okay, then I think we have removed that possibility of this being 21 and 22. I guess it could be 21 and 16 here. Yeah, that is possible. Maybe. We've removed the possibility of 16 and 22, though. Because the problem is on the Whisper 5 line, you have to have 2 lows and 2 highs here. And this must be, if we're missing a 2, it has to be high, low, high. But since we're missing a 2, it cannot be 4 and 9 here because 4 cannot be the middle digit on this Whisper 5 line because it's next to 2 unique digits. So it has to be 1 in the middle next to a 6 because you can't have 6, 1, 4, 9 because 3 can't be in between 7 and 8, which would be the remaining digits. So you cannot be missing 38. You cannot be missing a 2. So that removes 38 and 41. So this is not missing a 4 on the modular lines. So this cannot be 22. Can it ever be 21 as a sum? That would mean 16 would be here. And we'd be missing a 3. But how do you get to 21? 6 would also have to be next to the 1. 4 would have to be next to the 9. And again, you'd have to have this be low with 2 highs. Again, you have the same problem of 1, 6 doesn't work. And then this would be 1, 4, 9, 6 here, which does not add up to 21. So you can never have 21 here. Okay, so then this still works. Okay, so then this is still valid. You could have 20 and 17 here. That's possible. This being 1, 4, 6, 9 here. This would be 2, 7, and 8. So that does work. Okay, so then we still, okay, all the previous logic that I had then still works. So this cannot be 20 or this cannot be 21. This cannot be 16 for that same logic because then this must be, this has to be 20 or less, right? Okay. Can this ever be 18? I guess it could be, right? If this is, well, not this specifically is 8. Well, so far we have this being 16 and 17 are both fine. So we're not missing a 2. We are not missing 1, 2, 8, and 9. So we're missing either 3, 4, 6, or 7 on the Whisper 5 line. Along with a 5, obviously. Um, so if this is 33, this is 16 and 17. Therefore, this must have 20 and 18. If it's 34, it's 16 and 18. Okay. So again, 16, 17 means one of these is 20, the other has to be 18. So 16, 17. Um, yeah. So if we're missing 6 or 7, this has to be 9, 3, 4. Because we have to have one high and 2 lows next to it, and the only way that adds up to a sum that works is 16. Um, and then this would be 1, 2, 6, 8, which adds up to 17, or 1, 2, 7, 8, which adds up to 18. So that works. Then one of these is this is 18 and 20 as the largest digits. And then we have 17 and 20 as the largest digits with this is 34. If we're missing a 3 or 4, if we're missing a 3, this has to be 17 because it must be low with 2 highs, and we have to have 1, 4, 6, 9 here. That's 20. So this would be then 17 here. So we have 17 and 20 here. Okay. Oh, interesting. So it would have to be to 24 in this area. Huh. Okay. We'd have, again, 17 and 20 there. If we're missing a 3. 4 is not as restrictive. We just know 6 and 1 have to be here. That's all we know. Hmm. 3, 8, and 9 is 20. Plus 1. Oh, this would be 16 here. That's interesting. So we know we can have 17 here and 20. So 19 would have to be with 17 then. Is that possible? Um, how can you get 19 is kind of the question, right? You would have to have 3816. That doesn't no. 3916 and 278. That does work. Yeah, that does work. So you could have 19. Okay, well, what happens if you have 17 and 19? So the only way you have 19 as the largest one. So you could have 16, 17, 16, 18. You could have 20 and 17 to add up to 37. 19 and 18 does not work because you have to have 4, 9 as a combination and 1, 6 as a combination. And this would have to be... So this would be 4, 6, 1, 9, and you have 2, 7, 8 in that scenario. So that's why you can't have 19 and 18 together. 19 and 17 can only... 19 can only be with 17. So that what would that force this to be? So 19 and 17 force this to be 18 and 22. Then we'd have 21, 24. And 17, 18, 22. 21, 24, and we'd have to have 23 and 20, which could work. Okay, so 19 and 17 is a possibility. Dang it. Okay. Wait, is it? Hold up. 19 and 17 means this is 18 and 22. Oh, yeah. No, 23 and 20. 23 and 20. Okay. Um... Okay. I might have to look at the modular lines and how those add up. Hmm. Huh. What else do we have? They all seem valid. Okay, so if we're missing a 7, or a 6. This is 3, 8, 9. And then this becomes 1, 2, 6, 7, or 1, 2, sorry, 1, 2, 6, 8, or 1, 2, 7, 8. If we're missing a 3, this has to be 1, 9, 4, 9, 1, 6 in some order, with 1 and 9 being in the middle. And this is 2, 7, 8. We're missing a 4. That gives us a lot of flexibility. Oh, that's interesting. Every time we have a 16 here, this has to be 22, and this must be 23 that this adds up to, right? Because it has to be 16 to 23 as sums. So this would be 9 and 3 and 4 here. This would add up to 22. Huh, so that's interesting. So we're guaranteed one has to be one of these 4 digits, right? Does that tell us anything? I'm not really sure. That does mean this is 21 and 19 here. It feels like it's too broad, right? To be able to restrict on the entropy line. Maybe not. How do you sum up to 17, 18, or 19? Obviously you can't have 1, 2, 3, 4 be in one set. 1, 2, 3, 6 is 12, so that doesn't work. 9, 2, 3, 4 adds up to 18. 1, 8. Can you ever have 19? Probably. So 9, 2, 3, 4 adds up to 18, so that's valid. So, okay, so we have, this is valid. We have 16, 17. Do we have 18? I don't think the lower one, the smaller of the Whisper 5 line can be 18. You'd have to have 18 and 19, which would mean we're missing a 3, which means we have the 4, 9, 1, 6 pair, but this has to be low surrounded by 2 highs, and it can't be 1, 6 with the 9 being there. So no, you cannot have 18. Huh, the smaller one has to be 16 or 17 here, guaranteed. Okay. Oh. So this is guaranteed to be the lowest digit here. So if this is 16 as a low sum, then this is 22, 23. If this is 17, and this could be the 17 here too, right? This could be 20. It can't be 17 and 20. It could be 16 and 20, though. If that were the case, then this would be 22, 23. Huh. So the smaller one of the Whisper 5 lines adds up to 16 or 17 guaranteed. It cannot be 18 because 18 would have to have 19 with it. And the problem with that is that you'd have a 4-6 and a 1-9 pair, which could not be on the 3-cell Whisper 5 line. That's interesting. These could obviously still be 17 in all of these scenarios, but this is the guaranteed lower end of the boundary. Because we tried to have 16 here, and that doesn't work. Because that would be too many small sums, right? And then we'd have to have 22, 23 with no 20 here. Um... Um... Yeah. Wait, hold up. Can this ever actually be 24? I guess, yeah. 22, 23. This would be 17, 20. Because it can't be 24 and 20 here. Okay, yeah, that does work. We've shown 18 can be 9, 2, 3, 4 works. What about 17 or 19? Can we actually come up with that? So what if we have 1, 8, 3, 4? No, that's too small. 1 plus 8 is 9, plus 3 and 4 is 16. What about 1, 2, 6, 7? 1, 2. That's too small. That's 16 also. What about... Okay, so let's just do all the combinations then. It's like, okay, 1, 2, 3, 4, too small. 1, 2, 3, 6, too small. Those are all the combinations with 4 being there. 1, 2, 3, 4, 1, 2, 3, 6. 1, 2, 7, 4 is 14 too small. 1, 2, 7, 6, 16 too small. So that's all the 1, 2, 7s. 1, 8, 3, 4. Too small, it's 16. 1, 8, 3, 6 is 18. So we got 18 again. So that's so again 1, 8, 3, 4, 1, 8, 3, 6. 1, 8, 7, 4 is 20, which can't work because that's the other would sum to 20. And 1, 8, 7, 6 is 22, which means the other one's 18. So we've only proven 18 so far. Now we can't have 1. So we've done it with 1 and 8. We've done 1, 2, 3 as a set with both of them. 1, 2, 7 as a set with both of the 4 6s. We've done 1, 8, 3 and 1, 8, 7. So now it has to be 9. 9, 2, 3, 4 adds up to 18, which is 18 of 22. 9, 2, 3, 6. Oh, these are always going to be differences of 2 at most. So this has to be 18 and 22 here. Ah, I should have got that from the start. Well, that makes things much easier. Okay. So we know then. Right, so the tentropy lines, the swapping, you can only go from 20 to even sets, right? Because the difference between 1 and 9 is 8. The difference between 2 and 8 is 6. The difference between 3 and 7 is 4, and the difference between 4 and 6 is 2, all of which are even differences. So there's no way you can get an odd difference. So this has to be 18 on this tentropy line, and it must be 22 here. Wow, I spent all that time just like trying to figure that out. If I had just been it from the start. So this is guaranteed to be 18 and 22 on the entropy line, which means this cannot be 22 and 23. It's 21 and 24. Since this is 21 and 24, we don't have 22. We don't have 24 here. We don't have 18 as a possibility. So we need a 23. The only 23 that's possible is the tentropy line, the modular line. So this has to be 23. And we cannot have 16 because 16 to 24 doesn't form a set. So it's 17 guaranteed as a smaller one. Which means this must be low with 2 highs. So this obviously can't be 17. It's 17 and 19 or 17 and 20. We don't know if this is the smaller one, though. So we have 17 here. This can't be 17. So we have 19 or 20 here as a small one. Okay, so then these are the sets. We have 21 and 20. This is guaranteed to be 21 in size. This is guaranteed to be 24. The larger one, the smaller one here is 18. The larger one is 22. We have the smaller one be 17 here. And then the other one must be 19 or 20. So this is 19 or 20. We have the smaller one here be 19 or 20, and this must be 23. Okay. So this must be 19 and 20 in some sort of set. So it's 17 and 19 or 17 and 20. I might have to end this soon because I have a prior obligation that I need to get to. So we know it's 17 to 24. 24 with 2 odds and 2 evens. Can you ever have a 1? No. Right? 1, 6, 8, and 9. I guess it could be 1, 6, 8, 9. 17 and 19 means, or seven, it could be 17 and 19. So we are missing a 3 or a 4, right? It adds up to, the Whisper 5 lines adds up to 36 or 37. We're not sure which. So we're missing a low digit. So this must be a high digit. No, sorry, this must be a low digit next to 2 high digits. Guaranteed. So this cannot, it could be, this is 1, 2, or 3 here. And it's next to, it cannot be next to, it can't be, we have to have 1 and 6. So this cannot be 1. It's 2 or 3, which is next to 7, 8, or 9 here. So we are guaranteed 1 has to be, so 6 is one of these two. And then we have guaranteed 1 in one of these. Obviously this could be, oh, this has to be the 17, right? Because if this is not 17, no, it could be the larger one. It could be 3, 8, 9. It could be 20. So this is either 2 with 7 and 8, or it's 3 with 8 and 9. So this is 17 or this is 20. We don't know which. Okay, so this is, we don't need the high and low markings here. So if this is 3 with 8 and 9, then we have to have 1, 2, 6, 7. So this would be a 1, 7 pair. And this would be 2, 6. If this is 2, 7, 8, we'd have to have 9 in the middle. So it's 1 and 9. And then this is 3 and 6. Okay. Huh. Oh, I guess this could be... Yeah, this cannot ever be 2, 7, 9. It'd be too large, right? It'd match the sum here. So it's either 2, 7, 8, or 3, 8, 9. It cannot be 2, 8, 9. That would be 19, and that would be a wrong sum. 2, 8, 9 would force this to be 3 next to a 7 or 8, or 6 or 7, which is not possible. So this is 2, 7, 8, or 3, 8, 9. Either way, we're guaranteed 8 has to be one of those two. Hmm. 2, 7, 8 is 17. And it would be with 1, 3, 6, and 9, which is 19. 3, 8, 9. Oh, it can't be 3, 8, 9. If it's 3, 8, 9, that means 1, 2, 6, 7? Does that work? Yeah, it would be 1, 2, 6, 7, which adds up to 16, which we know is too small. So it has to be 2, 7, 8 here. So this is 2, 7, 8. Okay. So then this adds up to 17. Which means this adds up to 19. Which means this is 20 and 23. We don't know which one's which, though. So no 7 here. This is 1, 9 as a pair. Next to 3 and 6. Okay. 2 cannot be here, so 2 is on this part. So 2 has to be somewhere here. Okay, this can't... Remaining digits of row 7. We have 1, 3, 4, 5, 6, and 9. Okay. These have to be the same modular set because every 3 cells on this line is the same modular set. So this cannot be 5 here. One of these adds up to 20, the other one adds up to 23. So we're missing a 2 on the modular lines. So this can't be 2 either. We have guaranteed 1, 5, or 8 here. So either this is 1, 4 as a pair. That would force that to add up to 5. Is that possible? I don't think so. These cannot be 1, 9 or 3, 6 because they see both the 1, 9s and the 3, 6s. So this is 2, 4, 5, 7, 8 here. Can this actually be 1 and 4? That adds up to 5. That means these 2 digits would have to add up to 23 minus 5, which is 18, which 2 digits can never do. Or they add up to 20 minus 5, which is not possible either. Because this would have to be 2 modulo 3 and 0 modulo 3. And they add up to 15. That doesn't work. It can't be 6 and 9, cannot be 7 and 8. So this has to then be 3, 6, and 9. Therefore, one of these is 1 modulo 3, the other is 2 modulo 3. So we have 1, 4, 7 or 5, 8 there. This is 3, 6, and 9. One of these is 3, 6, or 9. The other one is 5, 8. And we have 1, 4, 7 on the ends. Okay. 5 is not on the tentropy line. Um, 6 and 9 adds up to 15. So what do these add up to is kind of the question, right? 3 and 6 add up to 9. So this is always going to add up to a 0 mod 3. Which means this is... That doesn't work. 1 mod 3 and 2 mod 3 necessarily add up to a 0 mod 3 also. But we need 20 and 23. I might have to end it here because I'm not completely sure that this is right. And we have to figure that out. Yeah, and I have a prior obligation that I need to take care of soon. Shoot. 20 is 2 mod 3, and 23 is also 2 mod 3. Hmm. That's not good. I don't know where I made the mistake. There is a mistake here somewhere, right? The problem with the modular lines is they must add up to the same modularity, and if we're missing a 2, we have to have 3, 6, and 9 doubled as a set somewhere. That's interesting. But I messed up somewhere then. Okay, I'm going to close it off because I have to get to my obligation. And, well, I'll see you on the next video. Hopefully, we'll solve this soon. I feel like we're very close to breaking it, but I just don't have the time to actually finish it off. Well, I'll see you in the next video. Take care.